A common strategy for implementing the order function is creating a function that contains all order-related logic. To maintain readability, this function can be divided into two subfunctions which are called within the primary order function, insert order function and mail customer function. These functions reside within the same application hosted on a specific machine. However, as your organization expands, the duty of managing notifications may fall to another team. This team deploys the mail customer function in a separate application, which runs on a machine under their supervision. The mail customer function now needs to be executed over the internet, and that is remote procedure call, aka RPC. RPC has been in use for several decades, with the most popular is gRPC, developed by Google. A key question arises regarding how a remote function can be understood by the caller, especially when they may be written in different programming languages. This is where the interface definition language comes in. It's used for defining data structure schemas and programming interfaces, typically in a .proto file. You may be wondering about the interchangeable use of gRPC and REST API. Here's a simple comparison. gRPC only operates with HTTP/2, while REST API is compatible with all HTTP versions. gRPC uses binary data transfer for increased performance, while REST API relies on JSON. API specifications are represented with .proto files in gRPC, while REST API uses OpenAPI. gRPC isn't broadly supported in browsers, making REST API the best choice for browser-server communication. Returning to our original solution, to keep the market offerings up to date, real-time updates on product availability are needed. Let's proceed with implementing this feature. Firstly, we'll create an update inventory function for this purpose. Secondly, the update inventory function will be invoked in the create order function. You might realize that incorporating additional logic needs modifications in two distinct places, implying a tightly coupled relationship. To address this, we'll use events in our solution. Following the creation of the order, we'll emit an order created event. Next, we listen to the order created event and send a notification to the customer. Now, let's revisit the update inventory feature. This time, you just need to create a handler that listens to the order created event and updates the inventory. This is how we achieve loosely coupled modules. This solution can be implemented using the observer design pattern or third-party library. Again, several modules managed by distinct teams and hosted on different machines. The event has to send over the internet. This is where the broker comes in and plays its role, receives these events and broadcasts them to subscribers who waiting for handle order created event. Some popularly used services for this purpose include Kafka, RabbitMQ, and Azure Service Bus. In summary, when using gRPC, a service dispatches a request and awaits a response. For two services to be loosely coupled, they should communicate by dispatching events via a broker.